It's radius, right?
It's the radius.
Okay.
So if you're driving along and you going, say, 50 miles per hour and you, through a neighborhood, and you take a sharp right turn, because R is so incredibly small, R becomes small, so the centripetal force, in order for you to be able to do it, or centripetal acceleration, would have to be huge. Your denominator gets small. That's why it's hard to maintain road coherence. Probably not the right words. It's why it's hard to take a sharp turn at a high speed.
And stay on the road.
Yeah, and not skid.
Yeah.
Because friction is the centripetal force. The higher V is, the lower R is, the more force that's required.
Okay, got you. And we are given the radius?
Yes.
Okay, cool.
I had a question.
Yes.
Could you explain why you divided by y cosine theta and mg?
I need to get rid of Y somehow,
Okay.
because it's one of my unknowns. And having done this enough, I just know that it's, in my mind, simpler just to divide one equation by the other one so that we consolidate that into a single entity,
Okay.
tangent.
Okay. Gotcha.
There are other ways of doing it, that's just, that was my mood at the moment. Did you want to do it a different way?
No, that's fine.
And then ultimately we get some answer that will, as usual, change your life for the better.
I got 24.33
Me too.
meters per second.
All right, so, a little over 50 miles an hour. So that is ideal. Now suppose you drive faster than that, what's gonna happen?
You know, skid up the ramp.
And if you drive slower?
You'll go down.
So now if we throw friction into it, add some realism. We throw friction into it, whether you're driving above that speed or below that speed affects the direction of friction. You drive above it, your car wants to go that way, so friction's acting down the ramp. Drive slower than that, the car wants to go this way, so forth.
Yeah.
And so that affects the answer. So let's take a look at, let's assume we're gonna drive faster than that. That also, all right. Let's go back to here. Move that. So assume V is greater than, I'm gonna just put V1, so in other words, the speed we got for the first answer. Now do recognize that the 24.33,
Yeah.
I need to refer to it later, 24.33. Do recognize that is a speed, that is not a velocity. Because the velocity, the direction is constantly changing, so it'd be very difficult to answer that. So therefore, friction is acting down the ramp this way, basically up that way. We also have to break friction up now. Now, we could go through the geometry of it. We actually don't have to. Because friction is perpendicular to the normal force, the hard part has already been done.
Oh.
So friction is acting left and down. The trig functions flip. This is going to be friction times the cosine of theta, whereas for normal force it was sine, and vertically, normal force was cosine, this would be sine.
You erased whatever was there and then put y sine of theta. What was there before?
It was y sine of theta, I wanted to move it
Just
up.
wanted to move it, okay.
So why did our sign split? The trig functions.
Why they flip? Because they're perpendicular to each other. That's the quick and dirty answer.
Gotcha. Okay.
Another way of looking at it is that friction is acting down the ramp at an angle here of theta,
Yeah.
and so that angle there is theta, so this would be friction sine theta and friction cosine theta.
Yep, okay. Yeah, cause y is, it's always acting into the, sorry, never mind. Making it
good?
more complicated.
All right, equations of motion.
Oh,
And it doesn't have to be Brooke, but Brooke, go for it if you want to.
one sec. Is it, okay.
Or if you don't feel like it, just say, I don't feel like doing it, one of you guys take it.
Okay, wait, it's F sine, well, can we still use the y cosine of theta and the y sine of theta, or are we?
Yeah, yeah, oh yeah, they're still
Okay,
there.
Cool, y cosine of theta minus, F sine of theta. Oh, this is getting confusing.
Y cosine of theta minus F sine of theta.
Is equal to
Minus one.
0.
Hold on.
What was that?
Minus
Minus weight,
Oh, is
Equals-
equal to 0.
okay?
And then, y sine of theta plus f cosine of theta is equal to m acceleration centripetal, yeah, that, centripetal acceleration,
There we go.
same thing.
We're gonna go through the similar process as we did before. I didn't actually give you a value of mu sub s. I think rubber on asphalt is somewhere around 0.8 or so. But since we're looking, oh, I guess I do need to actually state a problem here. Let's make it, what is the, if I give you mu sub s, what is the maximum angle it can be in the car not slip? No, that's slightly different. Let's change it to, once I give you mu sub s, what's the maximum speed that the car can go without slipping? There we go. Let's make that official. So, maximum speed. So car and car not slip. So we're looking for Vmax. So I have y cosine theta minus mu s y sine theta is equal to mg. And then y sine theta plus mu s y cosine theta is equal to m v squared over r.
What does the mu go with the y sine and y cosine?
All right, so friction, the two formulas for friction, if it's kinetic friction, in other words, there is sliding, it's that coefficient u sub k times the normal force.
Oh, okay, okay.
Static friction,
Same.
S of s is less than or equal to u s y. In other words, the static friction is always going to be enough to stop an object from moving until you hit that breaking point.
Right.
And that's the breaking point. And so, even though you've said, okay, I just want to finish the thought, because we're at an extreme, looking for that maximum speed, we're looking at that point where we're just at that breaking point. So that's why I'm using u sub sy for the friction.
I do have a question about that, though.
Yeah.
When we're calculating static friction, which I'm sure we'll get into, when it goes, I know in the equation it shows when it's above static friction, like for whatever that equals, we'll use kinetic friction. But is that only true? So like if you were to solve, we're about to solve for it, aren't we?
We're going to solve for v, but in this case.
The mu sub s times y.
Yes.
When we plug in our mu sub s and solve for static friction, how do we know whether that's above our kinetic friction so that we'd have to use kinetic? Is it only when it's a positive, or is it only?
Right. There are a couple things mixed up in there. So typically on a, say, box on ramp problem,
Yeah.
you assume, the first thing you do is check to see, are we going to exceed the maximum static?
Yeah.
So if you just plugged in USY into those formulas, assuming that one of your coordinate axes is in the direction of acceleration, if you get a negative acceleration, that would mean, oh, the thing is accelerating the other direction, which
Yeah.
doesn't always physically make sense. If it doesn't physically make sense, then that means it's actually, we did not exceed the maximum static, so it's still not moving.
Okay,
If we got a positive acceleration in that scenario I just set up, that means it is gonna slide, therefore we use kinetic.
okay, gotcha.
Does that answer?
Yeah, yeah,
All right, so now I'm faced with a situation again, even though I didn't give you the number, use of S officially, we'll assume it's known. We know mass, we know R, we're trying to find the maximum speed, so we don't know V, and we don't know the normal force again. Don't have to know the normal force, but we don't know it. I do have it on top and bottom right here, I can factor it out. Actually, I'm gonna do one other thing first. Now, typically in a problem like this, until, I don't know why it took me so long, but eventually figured out a simpler way of doing it. I do the division thing like I did before, mass cancels out, very similar to the exact same process we did before. Now I have this cosine and sine and cosine. I then did cross multiplication, so now I have a problem with sines and cosines in it. And the way you match those is you square both sides, so you have a sine squared and a cosine squared.
tangent squared.
Well,
Oh, it's equal to
That's
one. Yeah, no, that's,
that's only if you add them straight up, but you can't necessarily add them straight up. It becomes this huge mess where then you have to make sine squared into 1 minus cosine squared, or cosine squared into 1 minus sine squared. There's a long drawn out process, and you eventually
Yeah.
come out with several answers, of which only some of them make sense. And part of me wanted to go through that, just so you experience how much better this other method is.
can't we combine these?
How?
Y cosine plus, use of S, no, that's not right, because use of S of Y is in front of sine rather than just Y sine.
Yeah, that really messes things up. All right, so the technique on this one is I'm gonna multiply this by 1 over cosine of theta, and I'm gonna multiply this times 1 over cosine of theta. So I get y minus mu s, y tangent of theta is equal to mg over cosine theta. The other one, we'd have y tangent of theta plus mu s y is equal to mv squared over r cosine theta. That's a theta. Now we divide. The y's are going to cancel out on the left-hand side. You can factor it out and cancel it that way. Several ways of showing it, but I got 1 minus mu sub s tan theta over y plus, sorry, over y tan theta plus mu sub s. That y should not be there. Tan theta plus mu sub s is equal to m's cancel out, cosine thetas cancel out, and you're left with gr over v squared.
Where did R, oh, never mind. R is the radius,
Yes.
right? And the acceleration of a centripetal force is V squared over R?
Yes.
Okay.
Now I'm going to treat tan theta like it's its own thing right here. Matter of fact, I don't feel like writing tan theta, so I'm just going to make a capital T for that, just because I don't feel like writing it. I'm going to cross multiply, so I end up with 1 minus ut times v squared is equal to gr times t plus mu. Matter of fact, I'm getting lazy there too. I know it's static. With the static coefficient. Ultimately, so I'm solving for t, and then I'll solve for theta. So distributing, get v squared minus mu t v squared is equal to grt plus mu gr. Get my t's together, get everything else on the other side. And I hope this is still in screen. So we end up with, say, bring the t's over to the left, so I get v squared minus UGR is equal to UTV squared plus GRT. Factor the t out, I'm left with UV squared plus GR. And so ultimately, the tangent of theta, big T, is equal to v squared minus mu GR over mu v squared plus GR. And so now that's a question of what are you actually solving for? We're solving for v. Oh, so used to solving a different problem. We're solving for v, which means at this point, oh, right there. This is just math fun, just as an aside. We didn't actually have to do this to actually answer the question.
So
Yes?
you divided both equations
Yep.
by each other. mg over cosine divided by mv squared over r cosine theta would be, what you did down there was gr divided by v squared.
Yes. Not buying it?
There's a rule, I just can't remember. It's like 1/2 divided by 3/4. You put 4 up top with 1 and then 3 goes with 2. But I'm just trying to remember.
So fraction bar is just division.
Yeah.
So this is a over b divided by c over d, which is a over b divided by a fraction, the same as multiplying by the reciprocal, times d over c, and so you get ad over bc.
Okay,
So it's basically outer divided by inner.
okay, alright.
What is the capital T for? Is that just a
What-
placeholder for the tangent?
Yes.
Okay.
Other questions before we put a nail in this coffin? Try to stick through the heart? Shoot it with a silver bullet?
Feeling festive?
Killing mythological creatures is a festive thing? So this becomes the tangent of 40 degrees plus, oh, let's give an actual value there. Let's make US 0.8. Plus 0.8 over 1 minus 0.8 times the tangent of 40 degrees. That's v squared. We lost something. Oh, yeah, there's a GR here.
I was about to say.
Mistakes somewhere in my head.
No, I'm just trying to follow the, a step behind or something.
Anyone willing to be the first one to say what they got?
Punched it in on.
Yeah, I cleared all of mine halfway through.
Alright.
That's plus 0.8.
Plus 0.8.
I got 59.3.
That's V.
Yep, so meters per second.
I got
What you get?
3,518.33
Big square root?
square root.
Yeah, that's v squared.
Oh, my bad. Yes, 59.3, yeah.
Okay. Jacob, you have a worried look on your face.
I got 41.46.
I got 59.3.
So we got 3 against 1.
Yeah.
Alright, whichever the answer is.
In degree,
Yeah.
okay.
I think I see what I did wrong, never mind.
Alright. Now, there's one clue here that tells us we've done something right. There's something that at least makes sense. That without friction, you go about 20, it was a little over 24 meters per second. With friction, we should be able to go faster. And indeed we do. So we go from about 50 miles per hour to about 120 miles per hour. Something else that we have done is, remember that the first problem we had no friction at all, the second problem we threw it in. So if I throw friction out, in other words, if I make mu equals 0, we should be able to get the exact same formula we had before. So just as a check, partway along the way, if mu is equal to 0, this becomes tangent of theta is equal to v squared over gr, which is what we had before. So at least it passes the 2 quick and crude tests.
So what you're saying is we could have done all of that with that equation?
No,
No?
no, because I can't look at that equation and figure out where the pluses and minuses go in the mu's.
Gotcha, okay.
Yes, Ben?
Did you give us the, US?
I did eventually. I wrote it down there.
Yeah.
Now, I could have instead given that same V and the angle and asked you to find mu. Or, there's lots of variations of this. Primarily, it's usually playing around with